Hey everybody. So for this video, we're going to talk about a few things, specifically cerebrospinal fluid, also known as CSF, as well as different ventricles within the brain. Sounds a little weird. So we're going to talk about that. I may skip over a couple small components only because I don't want to make this video go for 10, 15 minutes. So let's jump right in. Cerebrospinal fluid. Break it down. Cerebrum, spinal, spine, and fluid. It's a fluid. Can only imagine where that's found. Sorry for my sarcasm, right? So fluid that's going to be found in your cerebrum and your spinal cord, right? So or in the areas, right? So with that said, CSF is going to be found in those two areas specifically in the central nervous system. It is a clear, colorless liquid that is functions to help make the brain more buoyant, basically reduce the weight of the brain, which is always nice, right, for the brain itself. So it's not always just resting on the bottom part of your skull. Nothing really good can come from that. As well as provide some protection, right? If you don't believe me, there's a really cool experiment. You take 2 glass jars, put an egg in each of them, and then you put water in one of those jars. So basically you'd have a glass with an egg floating around in the water. Then you take both jars, you shake them pretty violently, see what happens. You can use your imagination for a second. And then the reality is the one without the water, the egg's destroyed. The one in the water is fine. Why? Because when you're moving it around like that, it has to move through the water. It doesn't really have a chance to bang up against the glass. And that egg, in case you didn't know, is your brain. Super important. With that said, it's also really important for removing waste within the brain, all of those different metabolic wastes that are generated in your brain. As we mentioned earlier, your brain is doing a ton of metabolic activity because it needs to think and process and everything else you can imagine, literally. So with that said, really important for that, but also it's going to create a very stable chemical environment. It's going to have all the ions and chemicals that are needed for the brain to be successful. So they're always there and available to your brain because they're going to need them. CSF is produced in what's called the choroid plexus, which are found in a couple places, specifically the ventricles of the brain. Take a step back. We didn't talk about the heart yet, but a ventricle is basically just going to be an opening within an organ. So in this case, the brain, there are little pouches similar to a sinus in a way. They're going to be pouches that are filled with this liquid. All right. So it's not only that your brain is surrounded by this liquid, but there's going to be little compartments within the brain that are filled up with the fluid too, increased buoyancy and so forth. As we continue, there are going to be tight junctions within these choroid plexus, and they're going to form what's called the blood cerebrospinal fluid barrier, and this is going to help protect the brain. Here comes some images. Again, you can watch a video on ventricles right here. Right? So, something to keep in mind, the cerebrospinal fluid is constantly moving around the brain. It's kind of hard to see from this image, but there's arrows showing you how the cerebrospinal fluid is going to continually move throughout the brain so that it can help make sure that it's constantly flowing and replenishing the brain with different chemicals as well as removing those waste products like we talked about. So it's a constant flux. Stuff's always moving. The brain does have 4 of these CSF-filled ventricles, and each cerebral hemisphere houses at least a large lateral ventricle, and then as well as a third ventricle, which I'll show you in just a second. So there's multiple. So here you go. Here are 2 of the lateral ventricles. So within the brain, a little deeper, it's not on the surface, even though it might look like it in this image. A little bit deeper within the brain, you have these 2 large structures that are filled up with cerebrospinal fluid. And that's normal. If you look from this angle, you can see it as well, the lateral ventricles. 4th ventricle is down here, the base. So the point is just showing you that there are different ventricles of the brain that are really important for housing that cerebrospinal fluid. Along with that, we can also take a look at the spinal cord itself, and you can see that there is cerebrospinal fluid located within that spinal cord. So again, it's your brain and your spine. There are choroid plexus within each ventricle, and that's going to circulate throughout the ventricles and eventually make its way to the central canal of the spinal cord. So again, it's going to start up here. It's going to continue down the spinal cord. So that said, the CSF is going to be going throughout the whole central nervous system, all right? And that's why if they ever do a spinal tap, lower, right, it's in the subarachnoid space, you're able to get it way down here. We'll talk about this a little bit more later, but the point is you can get it down at the lower end of the spine. All right. So if you have any questions on that first part, let me know. But also I want to mention really quickly a disorder of the ventricles, specifically the cerebrospinal fluid not being able to flow. And this is called hydrocephalus. Hydro meaning water, cephalus meaning brain. So it's water brain. Here's a normal brain. You can see all like the lighter gray is the parts of the brain, and then the darker green is the ventricles. If there is a blockage and these ventricles fill with too much of this cerebrospinal fluid, you get this hydrocephalus, and it really is just the enlargement of the brain. It's not very good. You can only imagine what's going to happen here. So now the brain is going to start to expand kind of like a water balloon, and the brain itself is going to start to press up against the skull, as well as have pressure from the inside because of the ventricles filling. Just an example of a disorder that could happen. Now that we talked about the cerebrospinal fluid and the ventricles, please let me know if you have any questions.